Second white coat. Subscribe and like. Let's learn medicine together.
All right, today we're going to put on our detective hats and solve a really baffling case. The clues are subtle, our patient is just 3 years old, and the whole mystery is unfolding inside one of the most complex places imaginable, the human brain. Right? I mean, that's the big question. When the problem is completely hidden from view, doctors have to become investigators. They have to follow a trail of evidence, the patient's symptoms, to figure out not just what's wrong, but exactly where it's happening. So let's follow those first clues together. So our case kicks off with a very young patient, only 3, who's been brought in with some symptoms that are getting more and more concerning for his parents. Okay, here's the file. We've got a 3-year-old boy. For the past month, he's had these headaches that just keep getting worse. And here's a key detail. They're at their absolute worst when he's lying down. He's also been throwing up, but it's weird. It's only in the early morning, and it has nothing to do with what he's eaten. To top it all off, his vision's gotten blurry. Every single one of these is a puzzle piece. So now the real investigation begins. You know, a list of symptoms is just a bunch of random data until a good detective starts to see the connections. And in this case, 2 very clear patterns start to jump out. The first major clue is a big one, a really big one. All those initial symptoms we just talked about, the headache, the vomiting, the vision, they're all pointing their fingers at one thing, a dangerous buildup of pressure inside his skull. Let's connect these dots. Why are the headaches worse when he lies down? Well, because fluid drainage in the brain slows down then, which cranks up the pressure. That early morning vomiting, that's a classic sign that the brain's pressure centers are getting squeezed. And then, when doctors look into his eyes, they see it, papilledema. It's a swollen optic nerve, which is like a pressure gauge for the brain. The whole pattern is screaming a condition called obstructive hydrocephalus. Okay, so we know what the problem is. There's basically a plumbing backup in the brain, and it's causing all this pressure. But that just leads us to the next massive question. Where is the blockage? The brain's a big place. To find the source, we're going to need a much more specific clue. And that clue, the one that's going to break this case wide open, is waiting right there in the patient's exam. It's not just that his vision is blurry. It's about how he can, and more importantly, cannot move his eyes. And here it is, the smoking gun. The patient literally can't look up, and his eyelids are pulled back just a little bit. Now, this isn't just some random eye problem. It's a very specific collection of signs called Pineal syndrome. And this syndrome is a huge lead because it acts like a GPS, pointing to damage in one very precise location, the top part of the midbrain. Okay, so let's recap. We have 2 giant clues. Clue number 1, signs of a fluid blockage causing high pressure. Clue number 2, Pineal syndrome. With just those 2 pieces of evidence, we can start to zero in on a single culprit in a single location. To see how this all fits, let's just pull up a quick map of the brain. We're going to focus on the area right around the midbrain. And sitting right on top of it, in what you might call some incredibly critical real estate, is this tiny little structure called the pineal gland. Now let's look at the real-life anatomy. You see that really narrow channel? That's the aqueduct of Sylvius. It's a critical pipe for the brain's fluid. And just look at its location, it runs directly underneath the pineal gland. This proximity, this is the key to the entire mystery. And here it is. This is the aha moment. A single mass, like a tumor, growing right there in the pineal gland is perfectly positioned to cause both of our problems. As it gets bigger, it pushes down and squishes that aqueduct. Bam! You get the fluid blockage and all the pressure symptoms. At the exact same time, it's pushing backward and compressing the midbrain. Bam! You get Pineal syndrome and those specific eye problems. It's one location, one problem, causing 2 totally different sets of clues. It all fits perfectly. So we have our prime suspect, a mass in the pineal gland. The logical deduction is rock solid. Now it's time to see if the physical evidence actually confirms our theory. And there it is, the MRI scan from our patient's brain. And you can see it, clear as day, that bright mass located exactly where we predicted it would be, in the pineal region, pushing on everything around it. This is the photographic proof. This is what confirms the whole deduction. Now that we've nailed the location, we can get even more specific about what this is. In a young boy, the most likely kind of tumor you find in this exact spot is called a germinoma. Our patient unfortunately fits the classic profile just perfectly. And you know, just like in any good investigation, you have to rule out other suspects. What if the problem was somewhere else nearby? Well, if it were in the thalamus, we'd see sensory problems. We don't. If it were in the pons, he'd have trouble looking side to side, not up. And if it were the cerebellum, he'd have balance and coordination problems. None of that fits. The pineal gland is our only suspect left standing. So this whole case builds to a really powerful diagnostic rule. This is the key takeaway. When you see a child with those pressure symptoms, like the vomiting and the swollen optic nerve, and you combine that with the very specific eye signs of Paranod syndrome, your brain should immediately point to a pineal gland mass. That is the formula that cracked this case wide open. So, what does this all really teach us? I think this case is just a beautiful reminder that medicine, at its core, is still a science of observation and deduction. Yes, the high-tech MRI was absolutely essential to confirm it. But the mystery, that was pretty much solved before the patient ever even went into the scanner. It was solved by carefully listening and watching, and by recognizing the powerful patterns hidden in the clues.